And without further ado, please welcome, put your hands together for Dr. Jonathan Balcombe. Welcome.
Thank you, Beretta. I once spoke at a conference right after Jane Goodall. And that was a thrill for me, and her, of course. But I don't know, I might have just been outdone. Having a poem recited like that is a beautiful thing. Thank you for that, Beretta.
Yeah.
Beautiful. The 97 birds are. I'm a bird watcher. I love nature, and Beretta was asking me for some sort of stuff that wouldn't be in the publicly available material, some background information, and I figured better how many birds I've seen on this trip than flesh-eating parasites from Africa. That was going to be my next choice, but I thought I'd spare you that after lunch. It's true. It may be in my next book, actually.
Yeah, I might be able to, yeah.
If not, we'll...
I want to start out with a personal account from when I was 8 years old. I climbed into an aluminum rowboat with a rather elderly director at a summer camp north of Toronto, where I grew up in Canada. And he rowed us out into the bay about a quarter mile. And we spent the next 2 hours fishing. And even though I had a primitive little sapling pole with a hook on the end, I was quite effective. I caught 16 fish that night. Most of them were little ones that were tossed back into the water, but several of the bigger ones were kept for breakfast the next morning. Mr. Nelson did all the dirty work, baiting the hooks with writhing earthworms, pulling them out of the fish's faces, and plunging his knife into the skulls of the keepers. I was a sensitive boy with a soft spot for animals, and a lot of what went on in that boat disturbed me. But I rationalized, I reasoned, as we humans are so good at doing, that this kindly man didn't seem to think anything was wrong, so I figured it must be okay. And but I never took a shine to fishing. When it came time to bait my own hooks and pull them out of fish's mouths, I soon lost any interest. I just couldn't help seeing it from their perspective. That was 50 years ago next month. And to this day, we generally see fishes through one of two lenses, for the most part. A source of food and a source of recreation. A pleasant thing to spend a Sunday afternoon doing is catching fish, provided you're not the fish. Well, today I want to invite you to see these creatures through a different lens. I've spent the last 5 years swimming with, researching, and writing about fishes. And I did that because, as an ethologist, I spent quite a lot of time poring over journal literature and scientific articles. And I was becoming aware there's a lot of really cool stuff that fishes do, and most people haven't a clue about that. It's not filtering up to the general public's awareness. So I wanted to change that. That's why I wrote this book, What a Fish Knows, a copy of which I should have in my hands. I didn't think to bring one. There are a few copies in the bookstore. I'd be happy to sign them. I also have bookmarks that I can give anyone who wants them. And so that's what I've done. So I'm just going to, in my 4.5-hour lecture today, I'm just going to give you, sorry, 5-hour lecture. Punish you for that. I'm just going to give you a few highlights from the book. The first of which relates to the diversity of fishes. I want to impress upon you that we are actually living in an age, if not the age, of fish or fishes. I prefer to say fishes, by the way, as plural, because we generally say fish as a collective term. This is part of the problem. We lump them all together, just a fish. It's a way of diminishing them. You may not think of it that way, but I think it has that effect. And I think the language we use is important. So, like when I go birding, I don't say I saw 55 bird. I saw birds. So I saw fishes because they're individuals. So anyway, so that's my choice, and I explain that in the book. But we are living in an age of fishes, actually. Most of the species in existence today on the Earth are no older, have not been around any longer than Homo sapiens, our own species. And we generally accept we've not been around very long, about 1 million years, estimated 1 to 2 million years. In evolutionary time, that's not really very long. That's not to say fishes are new. They've been around on the planet a long, long time. In fact, if you compress the whole time that humans have been on Earth into 1 second, fishes have been around for about 4.5 minutes. So they are here. They've been here a long time. It's just they're evolving just as fast, or arguably, possibly faster than we are. And that's a common misperception, is that they're primitive. They're primitive in the sense they've been around a long time, but as I say, most of the ones alive today are relatively new. And they continue to evolve as they're faced with challenges from their environments, just as we do. There are two major groups. There's the cotyledons, or bony fishes, and then there's the chondrichthyans, or cartilaginous ones. The latter are the sharks and rays and skates. They are as different from the bony fishes. A shark is as different from a salmon as is a bird from a mammal. So we're really living among 6 major classes of vertebrates today. Issue? Hold it closer. Yeah, I'm really bad for that. If you're at the back and you're not hearing me, just remind me, because I tend to do that a lot. So I'll try and keep the microphone close. Thank you. Just want to share a few names of fishes. I love the way we creatively name them. Whoever came up with some of the fish names deserve prizes. I usually show slides, so normally you would get to see pictures, but you have to just imagine them. The clown triggerfish, a gorgeous reef fish with spots and dots, and some people are nodding in recognition. They know this fish. There's yellow, there's white, there's black. They're gorgeous. Triggerfishes are particularly brilliant fishes as well, so they've also got a really keen mind. I'm not so sure I'd want to be called a sarcastic fringe head. And don't call any of your relatives a hairy-jawed sack mouth. It doesn't usually go down very well. But those are a couple of deep-sea anglerfishes actually have those names. Then there's the Hawaiian species with the longest name. The name that English speakers would call it is the lovely name Picasso triggerfish, but the natives call it the Humu Humu Nuku Nuku Apua'a. I'll say that again into the microphone. Humu Humu Nuku Nuku Apua'a. There will be a quiz on that before you leave today, so make sure you have that memorized. It stands for the pig who sews with a needle and grunts like a pig. The fish who sews with a needle and grunts like a pig. I think I said that wrong. All right, enough. There is one other that I sometimes share, the inadvertently brutest fish name, but it's a family audience. I'm not going to share it today. You'll just have to look in the book for that one. Halicaris bivitatis is the Latin name, but I'm not giving you the common. Okay, so that's a little bit about the diversity of fishes. I want to dispense with the persistent, most annoying notion that fishes do not feel pain. I suspect most of the people here don't subscribe to that opinion. Nevertheless, there are a few scientists who continue to argue. I actually co-edited a journal called Animal Sentience. It's the first ever journal on animal feeling, how animals feel. And it's an online open access journal. Anyone can go online this afternoon or later and read that journal and read its contents. You will find an article in there, the very first major article we published, which was an argument from a physiologist from Australia. He's arguing why fishes do not feel pain. And we've published a number of rebuttals ever since that time, probably about 45 rebuttals. So most scientists who are thinking about this don't agree that fishes don't feel pain. They think they do feel pain. I'm just going to present to you one study that I think is a pretty clear illustration of pain in a fish. And by the way, when I cite studies, it doesn't mean endorsement. It doesn't mean I think that we should do these studies necessarily. I think we should be, as I say, dispense with the question of pain in fishes. I mean, the evidence is quite overwhelming that they do feel pain, in my view. But nevertheless, there are scientists who are still studying this because there's this debate. I think the debate should be really settled by now. In this study, they took zebrafishes, a commonly used species in studies, and they're maybe that long, they're stripy, they look kind of like zebra stripes, hence the name, beautiful little creatures. And they had about 30 or 40 in this study, and they put them in a complex tank with 2 chambers, a little bit like a house with 2 rooms. They were adjoining, and they were shared with the same water supply. But one chamber was dimly lit with lots of places to hide, rocks, vegetation. That's where little fishes like zebrafishes like to spend their time. And then it communicated with another chamber that was brightly lit with nothing in it. It was barren. And that's not the kind of place that a little fish likes to be because there's nowhere to hide, they feel exposed, they don't spend their time there. And sure enough, all of the fishes in the study spent pretty much the whole time in the first chamber and they didn't swim over to the other side. Then depending on who they were in the study, they injected them either with a saline solution, that is a solution that is liquid, it's a control, but it shouldn't cause any lasting pain. The other group, unfortunately, were injected with an acid solution, which if they can feel pain is going to hurt for a while. And then they watched them, and their behavior changed a bit, but they generally stayed away still from the barren chamber. They continued to spend pretty much all their time on this side, on the dimly lit places to hide chamber where they liked. And then the scientists dissolved a painkiller, lidocaine, in the undesirable side of the tank, the brightly lit barren chamber. And guess what happened? Some of these fishes started swimming across and hanging out in that side of the chamber. And it was only the ones who'd received the acid injection, not the ones who'd received the saline. So this study to me says 3 things. 1 is fishes are feeling pain. 2, they have the wherewithal and the resourcefulness to do something about it when you give them the opportunity, right? They'll swim over into and get that painkiller, the relief of pain. 3, and I think perhaps most convincing, they're willing to pay a cost to get pain relief. They're willing to go and swim where they would normally avoid. I don't want to swim in that barren chamber. I don't feel safe there. But, oh, wait a minute, I get pain relief. So it's worth being there for a little while. So that's what happened in that study. This is a paradigm that's been shown to demonstrate pain in rats and chickens, as if we need to demonstrate it. But nevertheless, scientists ask these questions. It is at least good that scientists are asking these questions now, given that there are a few people who still, in fact, a lot of fishermen like to believe that fishes don't feel pain. We do need the evidence, and the evidence is there. We probably don't need to collect any more, because the evidence, I think, from a study like that is pretty darn convincing. All right, time to bring up my cheat sheet, my little notes, to remind me what I was going to talk about next. Another common myth about fishes is that they have a sucky memory, that they don't remember very much. The 3-second memory of a goldfish, anyone ever heard that? I actually hadn't heard that when I started researching my book, but I've since seen it in advertising. I've seen that trope in a number of places. Don't know where it came from, but I can tell you that fishes remember perfectly well. I'll give you an example of a little fish called the frillfin goby. It's about 4 inches long, lives in the intercoastal area. It lives in what's called the intertidal zone, the rocky rock pool area between high tide and low tide. When it's low tide, they're hanging into these rock pools. And they do an amazing thing sometimes to escape danger. If, say, an octopus comes lurking or a big heron comes and is trying to catch them, they can jump from one tide pool to another. It raises the question, how do they know which way to jump, and how do they know how far to jump? How do they avoid making a leap of faith and ending up stranded on the rocks, dying, right? They do it. How do they do it? Well, a series of experiments done in, of all places, downtown New York City at the Museum of Natural History, starting in the late 1940s through the 1970s, demonstrated quite clearly what they do and how they do it. They learn that. They learn that rock pool area. And they learn it at high tide. They learn it when the water comes in and they can swim over it and among it. They swim down among the little nooks and crannies and they learn it. They get it in their head. In one trial, in one day they can learn it. And then they can jump accurately. They can avoid making that leap of faith. The way it was done is the scientist in New York City set up a fake tide pool zone, a bunch of depressions in the floor, and then he would fill it and then lower it down so it was high tide, low tide. He would simulate their environment, albeit in a somewhat artificial, unnatural setting. And he found that if a frillfin goby had had the opportunity to swim in that area at high tide when he filled it up with water, and then he took it out and they had them in the pools, in the low tide simulation, he found that they were accurate in jumping out from one pool to another when he prodded them and made them jump at about 98%. So almost perfect memory. If they had not had a high tide experience, 15%, which is about by chance. He calculated that if you took a chance direction jump, you'd have about a 15% chance of landing in a neighboring pool. So it quite clearly demonstrated they're memorizing this low tide environment at high tide. They're taking an aerial view, if you like, and being able to translate that somehow into a horizontal view. And they can do it in one trial, and they can do it 40 days later after they've had 40 days without any practice with it. After learning it 40 days previous, they can remember it. So that's called mental mapping by scientists, and it's a pretty remarkable mental feat, especially by such a little animal. Size really doesn't matter. I mean, little brains can do amazing things if they're important to the animal. There's a lot of other stuff about memory I could tell you. In fact, let me move on to another skill that fishes have that is related to memory. Recognition, individual recognition. There's pretty much no study of the social behavior of fishes that has failed to document that individuals in a group recognize other individuals as individuals. They recognize, just as you probably can recognize a bunch of people here because you've met them before, you met them today, and you're using vision mainly, and mostly they use vision as well. Fishes do the same thing. They have their shoal mates, they have their preferred fish they like to swim with, and they recognize them as individuals. In fact, aquarium fish keepers who live with fishes at their home have claimed for a long time they recognize me. They know it's me. You know, there can be 5 people in the room, and I walk in, and then the fish swims over because it's time. You know, they want me to feed them or something. So that's kind of the lore, if you like. But recently, a research team from Germany actually showed that they actually do recognize us. And in fact, they can recognize us by face. They can recognize us by face if we have no hair, if the hair is removed, if the ears are removed. So you can even take away some of the cues that we would use to recognize individuals, and they still recognize a human face. How do you test that, by the way? Well, you can train fishes to bump their noses against one of 2 symbols. You can there's certain fishes you can squirt water to at one target versus another. I have a really cool slide of that, but you're not going to see it today. In fact, I'm going to mention archerfish in just a moment. There's even evidence now of the possibility of self-recognition in fishes. The way that's studied in animals is you typically present them with a mirror after you put a mark on them that they don't know it's there. So the first study published in 1970 was done where they took chimpanzees, they anesthetized them, then they put a dot on their forehead, and then when the chimpanzees recovered, they presented them with a mirror. And they wanted to see how's that chimp going to respond to the mirror. If the chimp makes a threat display or looks behind the mirror or something like that, it suggests that they're not recognizing that image as them. But no, the chimps immediately, they looked at in the mirror and they started to try and touch the dot, and they clearly indicated that what they were seeing, they knew was themselves. Several other species, a few, have passed the mirror test. Not many. Great apes, elephants, dolphins, and a bird, a magpie, in a research study. Several magpies in this study. It hasn't properly been tested on fishes, but there's some evidence now that manta rays, the way they behaved in a captive setting, these huge rays with a 20-foot wingspan, a very big brain, long-lived, they behaved in front of a mirror when they passed the mirror in a way that suggested they didn't think it was another ray. They thought it was themselves. They were moving the tips of their fins and seemed to be regarding themselves in ways that sort of indicated that they were seeing themselves. So it's early going to know yet, but there'll be more studies on that, I suspect. But we have early evidence for self-recognition in a fish. What about tool use? This is something that wasn't that long ago that we thought we were the only tool users. That was being debunked a long time ago. And now there's many species known to use tools in various ways. And fishes are included. You can watch YouTube videos of a tusk fish, for instance, swimming to the sand and then using water as a tool by blowing it in two different ways, blowing it out of the mouth or turning away and closing the gill cover, kind of like a bellows to make the water puff of water that removes the sand, grabbing the mollusk that's under the sand, a little clam, and carrying it very deliberately, very purposefully to a particular location. In this case, a rock or a piece of coral that is then used as an anvil, also a tool, as the fish, with a very series of well-timed, coordinated head flicks and releases, smashes the unfortunate mollusk against the rock to open it up to get at the soft tissue inside.
What fish is that again?
That is a tusk fish, a blue-spotted tusk fish. It's been recorded in more than one species of tusk fish. I think there's a few other species that have been shown.
Actually breaks the mollusk.
Yes, it breaks the mollusk by hammering it against. Take a walnut in the shell in a swimming pool sometime and throw it against the wall of the pool and see how easy or not easy it is to open that. It's actually pretty hard because water is very viscous and the walnut slows down very fast. So it's quite an impressive bit of coordination, and it's a very fast head flick that little fish makes. And again, it was filmed by a professor at University of California, one of the campuses there, and it's been shown it's available on YouTube. You can actually watch this behavior. Back to the archerfish, which actually, no, not back to, I didn't really tell you about them. Remember I mentioned the fish that can squirt water? That's called the archerfish, named for its skill. There's about 4 or 5, maybe 6 species known, and they have this remarkable ability to use water as a tool, as a projectile, to catch food, to catch flying insects. They mostly feed underwater, but if they see a bee, well, maybe not a bee. If they see a moth or a fly or maybe a dragonfly flying over, they will squirt water at it and try and hit it, or perhaps perched on a leaf. So those are two types of targets they'll go after. So let me just describe a little bit about how they do that. First of all, it doesn't come factory programmed. They have to learn it. They have to develop the skill. In fact, studies from Germany, they seem to be doing a lot of interesting studies on fish in Germany, have shown that if you take a young archerfish who has never actually shot water at a target, they can't hit anything even moving half an inch a second. So very slow movement, they can't even hit that. But if you give them a chance to watch older, more experienced individuals firing water at targets without them doing it themselves, they learn it very well by observation. So it's called observational learning, and they get quite good at it when you give them the opportunity to do it themselves. So it is sort of an apprenticeship program. They learn as they go, and learning is part of being a conscious, cognitive creature. And they use at least two methods to catch the prey. Unfortunately, I can't put the microphone down, so we'll make the microphone the fish. Okay. So one way they do it is if the insect is flying pretty far away, like a foot or more. By the way, they can squirt water 10 feet, up to 10 feet. Then they will do a quarterback technique. They will squirt the water ahead, hoping to meet the insect when it gets there. So it's like a predictive tracking, right? So they go like that with the water. This is the water. This is the fish and the water. Okay, we all on board? Good. At least I am. And then, but however, if the prey is close, within about 7 inches, like that, they do a turn and shoot. So they rotate their body at the same rate that the insect is flying by, and then they shoot directly at it, and that way the water goes like that. So two different techniques they will use, at least 2, as far as we know, to catch their food. So it's a fairly flexible behavior. They will also aim water below an insect who's perched on a leaf, because if you shoot at the insect, you're apt to knock it further onto land, which is not going to help you. You want it to fall into the water, so they tend to shoot just below or maybe above the insect so it drops off when it gets jolted. I'm going to use the word jolted again in a little bit, because that's a great word for describing fish behavior. And now we'll take a 30-second pause for the airplane to go by. How is it? Can you still hear me over the airplane?
Oh, yeah.
Just about? Okay, I'll keep going. Can fishes innovate? I've talked about tool use. I just want to share a little study of cods, which were in captivity, and they had all been marked with a plastic tag on their back. So they each had a little plastic tag sticking out of their back. And the way they were fed in this study, and this was not a study of innovation by cods, it was just happened to be happenstance discovery. Sometimes you have happy accidents in science. And what happened was, the way they fed themselves was they would pull a string. It was a string that hung into the water with a loop on it. And the cod could swim up and pull that string with the mouth, and it would release 1 pellet of food every time they did that. Well, it turns out some of the cods, by chance, it just, when they swam by, the loop hooked over their plastic tag on their back. And so when they swam away, it pulled the loop and caused the food to drop. And these fishes who had this happen accidentally realized it's like, hey, this is actually pretty good. This works better. I can get to that pellet of food before anyone else does because my mouth is free. I don't have to pull and then go over. So they actually, some of them started to use this deliberately. They started to deliberately swim in such a way as to hook the loop over the tag and get the food that way. So that was an interesting little discovery, and that was published in a scientific journal about 2 or 3 years ago. I want to talk a little bit about communication in fishes. I mentioned individual recognition. They communicate by sight. They are very visual animals. Some fishes have huge eyes. And by the way, those eyes are served by the same 6 muscles that we have. They have the same names that rotate the eyes. If you look at fishes in an aquarium, if they're really small, you may think that they're just staring straight ahead and they don't really move their eyes. But in fact, they have muscles that serve those eyes, and those eyes are turning often. And if you look at bigger fishes, you can really very clearly see them turning their eyes. There's some fishes, like puffer fishes, who have both eyes at the front of the head, and that's probably why they're on the cover of my book, because we relate to fishes who have eyes in the front of their heads. They look a bit more like us. So they have kind of that binocular vision. But fishes do also communicate a lot by touch. They communicate by smell. In fact, there's a fear chemical that fishes will release when they're afraid, and it's a signal to other fish. It's like, whoa, there's some danger nearby, we better be careful. So that's a nice way they help each other. And we don't think about fishes using sound because we don't generally hear anything. Well, guess what? We hear in the air, right? Our hearing is adapted to hearing in the air. We can hear stuff underwater, but it's kind of muted. They hear very well underwater, and sound does propagate very well underwater. And so a lot of fish communication is in sound. They make purrs, chirps, pops, cracks, all sorts of sounds. And I list about 25 different terms that are... Some fish are actually named for the sounds they make, like the humu humu nuku nuku apu a. Oh, I said it wrong. The one who grunts like a pig. That's probably named for the sound they make. But also grunts. There's a fish called, a group of fishes called grunts that are named for that. There's others, toadfishes, I think, may be named for their, although they look kind of toad-like. But there are a few examples that escape me right now. But I did want to ask you, anyone ever heard of flatulent communication? I don't usually get many hands up for that. However, well, yes, humans or fishes, yeah. Perhaps not amongst humans, although I don't know, some people I know. But in herrings, it has been scientifically documented that herrings do fart to communicate with each other. They release bubbles, sometimes for as long as 7 seconds in a row. Try that at home. And it's a way to make a sound that other herrings will use. It's been shown that they do this more per capita in larger schools, so it appears to have a social function. It's not known what the function is yet, but they do it. And the scientists, in their playfulness, called them frequent repetitive tics. I'll let you do the acronym for that. All right, what else do I have on communication? Referential communication. Okay, now we're going to get really sophisticated. Now this, to me, is pretty mind-blowingly sophisticated for any animal. It's very, very rare in nature for animals to use gestures to communicate specific message to each other. This is not only that in a fish, but it's across species. So it's one species making a referential gesture to another fish. And you can watch YouTube videos of this too. It happens between groupers, which are large, chunky, predatory fishes of reefs, and moray eels, which are large, not chunky, predatory fishes of reefs. And they have complementary hunting styles. And what happens is a grouper will approach, if he or she is hungry, wants to go feed and hunt, they will approach a moray eel to try and recruit them to go with them. And it's probably not willy-nilly. They don't approach any moray eel. It's a specific individual who they know lives just over in that little crevice over there. Let's swim over there, and I'll do my head shake, which is their gesture. It's essentially, that's the invitation. Sometimes they do a whole body shimmy, but it's essentially, that conveys to the moray eel, I'm hungry, I'm going hunting, will you come along with me, please? And the reason they say please is because it's been shown by careful observational studies that their success rate per capita is considerably higher if they hunt together. And the way it works is they have complementary hunting styles, because moray eels are like ferrets of the water. They can go into nooks and crannies of the reef that the big chunky grouper cannot go. And so if the moray may catch something in there, but if the moray flushes the fish out, if the fish manages to escape the moray, where's the little fish going to go? Into the open water. And who's waiting there? The grouper's waiting there. So that poor little fish doesn't really have any options. One of the two is going to get fed. And so when they hunt together, they're more successful. And it's not known how this evolved, but it's been carefully studied also in captive situations in the University of Cambridge University in England. They actually they took pictures of moray eels and laminated them, so they made them look like real moray eels, and they would control them with pulleys and strings and make the moray eel more or less cooperative. And the grouper, having been exposed to a more and a less cooperative moray, was more likely to work with the cooperative one the next day. So they're very selective about who they work with. They quickly learn to recognize a cooperative one. Groupers will also point to prey who's hiding in the reef. If there's a moray nearby, essentially saying, look, they'll spend as much as 23 minutes pointing straight down in this sort of pointing gesture. They'll also go and recruit the moray and bring them back. A clever science writer in England named Ed Young summed it all up with a rather familiar jingle. If your prey's in a hole and you don't have a pole, fetch a moray. So that's referential gesturing or communication by a fish. It is considered very high level, sophisticated cognitive behavior by any animal, and we have an example, a very rare example, and it's done by fishes. Can fishes be virtuous? Can they be self-sacrificial in their behavior? I mean, I think there's something to be said for that with the moray-grouper interaction, but it gets even more, I think, obviously virtuous among rabbit fishes. This is a pretty reef fish. There's many species. They're sort of yellow and black, mid-sized, gorgeous creatures. They typically forage in pairs. They're not hunters like groupers or morays. They actually are algae feeders, mostly. And when they're feeding, how are we doing for time, by the way, Marita? How are we? We are 20 minutes or so far, 25?
I would say a half hour.
Half hour? Okay, that's good. I'm on pace then. I just wanted to make sure. Yeah, they feed in pairs, and the way it works is, well, one of them is head down, vulnerable in the reef, kind of out of view, not aware of some moray coming along to catch them. There's the other one who's playing lookout, who's face up. And I have this great slide from the paper that was published that shows 4 different pairs of different species of rabbitfish. And one of them is down in the reef, and the other one is like literally almost swimming vertically, but very much pointing upwards. Not feeding, not yet, because of course this is a cooperative arrangement. They trade off. So after a few minutes, the one who's been feeding swims up and says, I don't know if they say anything, they may do actually, but they play lookout for a while, and then the other one swims down and gets to eat. So everybody gets to feed safely in exchange for a little bit of a favor, a little bit of a delayed gratification, if you like. So we often think of animals as, they don't know how to delay gratification, they want it right now, but no, rabbitfishes are willing to wait a few minutes to do a favor to the other one, who will return the favor. That, by the way, is called reciprocal altruism, another bit of jargon that's nice to know. You might be tested on that tomorrow, so make sure you have it memorized. Reciprocal altruism Can be unrelated individuals, no kin selection going on there. And it's virtuous because it's self-sacrificial. Now I come to what is arguably not just the most sophisticated mutualism in animals or in fishes, but perhaps in animals, and it's certainly very well studied. It's a very complex social relationship called the cleaner-client mutualism. Hands up if you've heard of the cleaner-client mutualism. Okay. Okay, some of you have read my book, right? Thank you. Great. I can't take credit for it. I'm a synthesizer. I take the science that brilliant scientists have done and published in their journals, and I bring it all together. I just have to share some of this with you because it's so cool what goes on a reef between cleaners and their clients. They don't call themselves clients, but that's essentially their role. It's a business relationship, it's a mutualism, it's a symbiosis where both parties benefit. The two parties are cleaner fishes, which are usually the blue-striped cleaner wrasse, but there's other species. There's a little fish, long fish with little stripes, beautiful fish. They advertise they're open for business. You know, barbers have the rotating stripes thing. These guys swim vertically. They almost look the same thing. In fact, someone's going to discover them spinning around. It's going to be an exact match with the barber. They don't clip hair, however. They remove parasites from their clients. So the cleaners, early in the morning, they're very busy little creatures. They advertise they're open for business, and clients will literally, in some cases, line up to wait their turn to be serviced by cleaners. The cleaners fuss over them, they pluck over them, the clients open their mouths, the cleaners swim into the mouth, they never get eaten. It's not a good business relationship to eat your business partner. It doesn't maintain good relations, right? It's never been documented. Sharks will swim vertically to indicate they're ready to be clean. Other fish will swim up and open their mouths and open their gills. They never eat the clients. And so it's virtuous in its own way. And so the way it works, of course, is the cleaners get food, algae and sloughing skin and what have you, and of course parasites is food, and the clients get a parasite removal service and a spa treatment. Because it obviously feels really good. It feels really good. It's nice to have the parasites removed, but cleaners go beyond that. They'll sometimes pause from parasite removal and they'll flutter their pectoral fins against the clients to give them a little massage. Now, you may wonder, wait a minute here, why would they go to that trouble? I mean, they're already removing parasites. Isn't that enough? Well, it gets Machiavellian. There is a reason they do that. They're currying favor. They want the clients to like them. Why? Well, the clients could go to someone else. And it is, after all, the cleaners' living. The cleaners make a living. This is their food. They service sometimes as many as 2,000 clients in one day. They are busy little fishes. And that's not all 2,000 different individuals. Sometimes it's clients who become almost addicted to this. They come back dozens of times a day. It's been shown that cleaners are very good at tracking how often clients come, because if that client was here just 10 minutes ago, it's like, well, they're not going to have many parasites, so we're not going to spend much time on them. If it's been 5 days, they're going to probably spend a lot more time because there's more food to be had. But there's other complications here. There's also, now I come to the word jolt. Remember I said I would mention the word jolt again? Mm-hmm. Well, here it is. Sometimes, well, let me put it this way. The favorite food of a cleaner fish is mucus. That is the slimy outer layer that protects the fish. You know how fishes are kind of slimy and slippery? That's a mucus layer. It turns out it's very nutritious, and it's apparently very delicious. I haven't tried it myself, but cleaners love it. And so they will occasionally do what's called mucus nipping. If they can get away with it, they'll mucus nip. Mucus nipping is not welcomed by clients. They don't like to be mucus nipped. It generally makes them jolt. And the jolting probably is three possible reasons. One is that it hurts a little bit. Two is that it communicates to the cleaner, I'm on to you. You just mucus nipped. I'm aware of that. You made me jolt. It also communicates to other clients in the queue, hey, you may want to watch out for these cleaners. They're not doing such a great job today. That's probably why cleaners will curry favor by massaging, by caressing, doing these extra gratuitous caresses. So, because the clients can go somewhere else. So this is just some of the stuff that's been described in what must be well over 150 published studies so far of this very complex relationship. There's some more I could tell about it, but time is limited. But there's also more that's going to be discovered. But it is a very complicated, truly Machiavellian social relationship between species. By the way, there's more than 100 known client species. There are many different species of fish who serve as clients for the cleaners. And there's also many different kinds of cleaners as well. So it's very complicated. I want to mention the word pleasure. It's a dear subject to me. I've written 2 books about pleasure. Pleasurable Kingdom and The Exalted Ark. Pleasurable Kingdom is available here, by the way. But I like to mention it because we often don't think of animals in the pleasurable context. We talk a lot about pain and suffering, which is very important. But I think it's really important to recognize that an animal can feel pleasure as well. We know pleasure is important in our lives. It informs and motivates a lot of the behaviors we do, what we wear, what kind of entertainment we seek, what kind of food we like to eat. It's pleasurable, and we look forward to that. Are we to think, really, that we're the only ones? I spent 10 years studying biology at 3 different universities, and I don't remember a single occasion where animal behavior was mentioned in the context of feeling good, of pleasure. We really missed the boat on that. That really motivated me to write those books. But I just want to come back to that. The pleasure of touch is clearly very important in animals' lives. The caressing by the cleaner fishes is an example. There's another study I describe in the book that I don't have time to here, in which fishes will, when they're really stressed and anxious, will go and get strokes. In this study, they had a mechanical wand that looked just like a cleaner fish, and they would swim up to it and get strokes. If it was not moving, they would ignore it because they couldn't get stroke from it, and their stress levels came down. So fishes use pleasure to get de-stressed, to feel more comfortable, just as we go to massage therapists, just as we may touch a trusted person, someone we like, to convey to them that we accept them, etc. And so pleasures, we need to recognize pleasure is important. And pleasure's importance has great moral significance, because if life feels good, if something can feel good, if there are pleasures and rewards in life, it means life's worth living. It means you have a quality of life. And that means that death is harmful. So there's all sorts of trickle-down effects from that awareness that animals feel pleasure. I'm just going to finish up very briefly with just a little bit about our troubled relationship with fishes, because I'm on a mission in my work, in my speaking, in my writing. It's not just, hey, aren't animals cool? It's also, we need to look in the mirror and recognize that we have a relationship with these animals, and a lot needs fixing. We're very exploitative of fishes. We've really given them a raw deal. We catch them in nets. We catch them on barbed hooks. If you're caught in a net, you're likely to get crushed under the weight of tens of thousands of other fishes if it's a commercial net. You can watch YouTube videos of nets being hauled on board, and fishes who are decompressing because they're being raised up from the depths, they're being crushed, or if they make it alive onto the boat deck, they suffocate. It's also a very wasteful industry because there's a lot of so-called bycatch. You may have heard that term, bycatch. It's essentially non-target, unwanted catch. A shrimp vessel who's trying to catch shrimp. Shrimp is the most notorious of them all. Very high bycatch levels, sometimes up to 90%. 90% of the catch in the net when it comes up is not shrimp. It's dumped out, dead or dying on the deck, usually thrown back overboard. Very wasteful. It's been estimated we produce 200 million pounds of bycatch per day. So, bycatch is almost a sterile word. It's really dead, dying marine life. And we've lost approximately half of all our marine life since 1970 based on some scientific estimates. So there's a number of problems with our relationship with fishes. I'm not going to go into a great deal of detail. I'm going to say this, though. 98 of every 100 animals that humans kill, and by the way, we kill about 200 billion to 1 trillion per year. Very hard to estimate when they're measured in hundreds of millions of tons. 98 of every 100 animals that humans kill are to be eaten, be put in our mouths, which is why the American Vegan Society and other groups, Anna Negron and her work, Nutrition and Health, the vegan message, the vegetarian message is so important, because it's so not just helpful for us in terms of our health, but it's the most important thing we can do to help animals is to not eat them, is to take ourselves out of that whole chain of economics where we're sustaining these horribly, really unsustainable industries by funding them. We go buy food that's made from this fish. We go buy fish. We're funding the fishers. So that's the most effective, direct way we can affect that. I'm going to close with a story. Not a poem, unfortunately, not by a Hayden poem. I'd like to do that. I'm going to memorize one. But a brief story from somebody who lives in Florida. I've learned as a science writer, people really relate to stories. Science can get to here, but stories often get to here. So I'm just going to share you one story about a discus fish, a very popular aquarium fish named Jasper. He was blue. They come in different colors, but he was blue, and Karen lived with him for many years. And he probably got a little lonely in his tank during the day when she was at work. So when she came home, they would play a little game where she'd run back and forth in front of the tank, and Jasper would swim back and forth with her. It was a game, and they connected through that. And then she would cup her hands. I'm just going to shout for the last part. I'm just going to... no, I'm not going to shout. All right, I'll just do my best gesture.
Want me to hold that?
It's okay. I'll manage. She would cup her hands in the water and lower them into the water like this. And Jasper would swim onto his side and swim into her cupped hands and just lie there on his side
Wow.
while she stroked him with her thumbs gently.
Jeez.
And if you doubt that, if you think I'm making this up, you're just not logging enough hours on YouTube. It's true. You can go on YouTube, you can watch people handling their fishes, picking them up out of the water, the fish trusts them, stroking them, the fish gets tossed in, it swims back. You can literally see videos like that. These guys really can connect with each other and with other humans. And I mention that story partly because it's emblematic of the kind of relationship we can have with these creatures. We can connect with them individuals. I'm not saying, you know, we have to go out and swim with the farting herrings, but we can go and snorkel and watch them, and they are really beautiful to watch in their schools. But we can also recognize that they're individuals. They're not just alive, they have lives. They don't just have biology, they have biographies. They're individuals with unique lives that I would say are valuable to them. They have intrinsic value. And for all those reasons, and for the perhaps overarching reason of karma, that when we're good to them, when we respect them, I think we're talking about a society that's generally more compassionate and more respectful of each other. And that's the kind of society that I want to live in. Thank you very much.